Great. So hello, everyone, and thank you for attending the talk today. Hi, Boyka. Yeah. So some of you might already know me, some not. My name is Negar, Orangi. So my last name has two parts, but I go by Orangi. I joined GGC in 2020 in the middle of pandemic, and I'm not sure, like I have seen some of you, but not all of you. So today I'm going to present my recent work, which is a artificial intelligence-based model. And in this work, we have used respiratory notes from the physicians to build a predictive model for the early detection of COPD. What is COPD? So I'm going to talk a little bit about, in the background, I'm going to talk about the COPD, the disease that I have studied here. And since we will use, I'm going to take off my mask. Since we have used text data in this study, I will go over just a very basic concept of natural language processing. And then in the methods, I have used 3 different machine learning methods, and I will very briefly go over those methods. And then I have my results. I will share my results, and then the discussion and the future work that we have. So some background about what is COPD, chronic obstructive pulmonary disease. This is a disease which refers to the group of diseases related to the lung, and they are mainly related to the breathing, like breathing problems, and it is because of the blockage in the airflow. Funny picture. So this COPD is a major public health, and in the United States, around 60 million people are already diagnosed with COPD. And these patients are really in a daily risk of losing control, exacerbation, and flare-up. But this risk could be controlled by using like decision-making assisting tools and predictive models. And this is a very active field, and recently a lot of predictive models have been developed. In this study, we proposed and developed a predictive model for the early detection of COPD patients and their exacerbation. In this study, we have used text data, which in the next slide, I'm going to share the data that I have, and I will let you know what we have. So I think this is not. So this is not showing all of my slide, I think. But, okay. So yeah, the last one is not here. So in this study, we have used natural language processing, which I'm going to talk about it in a bit. We use natural language processing to convert the text data from the notes physician notes that we had. We converted them to numerical data and built up machine learning models on using those data. So the data set that I have used is MIMIC3 data set. This is a clinical data set from MART information, from medical information MART, intensive care units from a hospital in Boston, Massachusetts, and it has the data for hundreds of thousands of patients who hospitalized during 2001 to 2012. And this data set is a product of an NIH-sponsored research by MIT, Philips Healthcare, and Beth Israel Medical Center. So let me first talk about this data set. So this data set, I think it has 11 tables, but I have used just 2 tables from this data set. The first table is the admission data set. So it has like general information about the patients who have been hospitalized. And there is another table, notes table, which I have merged the table with the admission table. And it has over 3 million notes the physician notes, the notes that have been provided by the nurses for these patients. But because I was mostly interested in studying the COPD, I have filtered those notes because the category of notes, like I think they have 6 categories, like physician notes, nurse notes, discharge summary notes, and respiratory notes. So I have filtered the data set to just the patients who have been hospitalized here, and they have respiratory notes. And I think I had 63,000 patients. Not me, like data for the patients. So here I have a very high level pipeline for the study that I have done. So I am going to go over these step by step. And again, I will share it as we move forward. I will share this as we move forward because I don't want you to kind of feel overwhelmed or confused. So we are going to start with natural language processing. Why we do this? Because as I said, the data I have, it is text data. And we are going to do some cleanup on this text data, and we are going to convert them to a numerical data that machine learning can work with. And then we are going to partition our data set to 2 parts, the training part and the test part. And we are going to develop the model based on the training data set. And then we will use the test data set to compare, to see, to compare the predictive results with the ground truth and see what is the accuracy. So in general, we have a training data set and we have the labels if these patients have been diagnosed as COPD or not. And then we have the machine learning method models. We have 3 of them. We train a classifier. We use the trained classifier on the test data, and we make predictions. Then we compare our predictions with the ground truths, which are the labels, the real labels, because test data set is a data set that the model has never seen. So the prediction versus the ground truths, and based on that, we are going to find what is the accuracy of the model. So this is in general what we are doing. So let me start with natural language processing. What is natural language processing? Natural language processing is a branch of artificial intelligence, and it deals with interaction between computers and human beings. So basically, the plan is enabling computers to understand the natural language as human being does. There are a lot of applications. I have some of them, for example, spam detection. There we get emails, and some of them are spam, some of them are not spam. So the spam detection can help, to categorize the emails. We have sentiment analysis. There are a lot of data out there in the internet. For example, there's a product, or people leave reviews for a product or a movie. So sentiment analysis can be used to see how people like it. Like, are people happy about this, for example? Even do people like this certain product? Machine translation, like Google Translator, speaker recognition, like Siri, Google Assistant, Alexa, virtual agents and chatbots, and so many. So every natural language processing starts with data pre-processing. What is data pre-processing? It involves cleaning the data, the text data that we have, and preparing it for the machine learning, preparing it and putting it in a frameable work and highlighting the features so the machine learning can work, the model can work with it. So there are a lot of steps that can be done. And the most important ones, I have them in like bullet points. For example, removing new lines in the text data, the punctuations, carriage note, returns, replacing missing data with the spaces, then tokenization. I'm going to talk about tokenization. The next step is removing stop words. I will also talk about this, and text normalization, and also this. So all of these are called pre-processing the data. What is tokenization? So by tokenization, say you have a sentence or a physician note. Basically, it is breaking the sentence into words, like we call them tokens. For example, I have this sentence tokenization is one of the many tasks a data scientist do whenever cleaning and preparing data. So what are the tokens? Tokenization is one of the many, and so on. Like as we move forward and do data pre-processing and cleaning, we are going to remove some of these tokens, which I am going to talk about. One of the things that can be considered to be removed is stop words. Stop words are the tokens which don't add any information to our data. So we are not looking at the sentences. At the end of the day, we are going to look at bag of tokens. So words like a and the, they are not going to add any information to our bag of words. So they can be safely removed. There are some defined built-in stop words in Python, which I have used, but as we move forward, I have added some other stop words to my study. The next step of pre-processing is text normalization. Again, there are a lot of ways that we can do, but the most important ones is stemming and lemmatization. What is stemming? So you have tokens, and some of them, they have same stems. For example, say I have stem play, plays, and played. All of them have the same stem. So when we do stemming, all of these are considered just as one token. In lemmatization, again, it is doing kind of stemming, but it doesn't look at the stem. It looks at the content of the context, the context, and this is called lemmatization. So both of them kind of, they are reducing the number of tokens, because later on we are going to look at the frequencies, and we don't want to have frequency for the same tokens, which have like basically the same meaning. So we have text data, we did some cleaning, and after that, we created the tokens. If we put these tokens in a bag, this is called bag of words. So bag of words is a method of extracting features from the document that we have. So here I have two sentences. Let's look at the bag of words for this. So this is the first sentence followed by another sentence. And then I have, this is the second sentence followed to demonstrate bag of words. So if I want to consider bag of words, you see that both of them have this. So if I consider bag of words, I don't need to repeat them. I'm going to consider their frequency, of course. So this is the first sentence. Like normally it has like the first one. And then when we start the second one, we don't repeat this because we are looking at unique tokens, and then we will consider their frequencies. We consider their frequencies of tokens to create a document term matrix. Document term matrix is a matrix that describes the frequency of terms in the document. So we had this example. So document term matrix is going to have the first one, the first row is going to take care of the features in your document. They are normally ordered in alphabetical order, and every row, this is related to the first sentence, and this is related to the second sentence. So if you, like in the first sentence, we don't have bag, it is why the frequency is 0, but in the second sentence, we have bag at the end, so the frequency is 1. We don't have demonstrate in the, sorry, I think the setting changed. This was supposed to be demonstrate. This is not another line. So, yeah. So the demonstrate, the frequency is 0, here is 1, and look at this one. The sentence, the frequency is 2 in the first one. That is because we have done stem, like I have considered stemming. Sentence and sentences, instead of having 2 different tokens, they consider as 1 token, and the frequency is 2. So in my study, I said that we had patients, 63,000 patients, and we looked at their respiratory notes provided by the physicians. The notes for every patient, and the document term matrix is the features, right? The tokens and the frequencies. And we are going to use this frequency matrix as our data set and build models. The thing is, there is a problem. As you can guess, the documentary matrix is going to have a very big dimension because like consider all of the tokens. And this is not just about this. In a lot of machine learning models, when we have a lot of features, passing all of the features to the model is not a good idea because it can. I forgot to record it. Oh, you got it. Sorry. I got this right. So, yeah. So, what we do, we can use dimensional reduction methods to kind of decrease the dimension. And this can be done in different ways. Yes. So in this study, we have used PLS principle, and there is another one, principal component analysis, which is normally done in unsupervised methods. But here we have done partial least square regression method to kind of do the dimensional reduction. And instead of working with so many features, just use a reasonable number of features, which are more informative and enough. And at the same time, our model has a reasonable performance. Let me very briefly talk about PLS, the partial least square regression. And also, I will talk about the three machine learning methods that I have used before I share my results. So PLS regression is a technique used with the data that have correlated variables. So PLS, what it does, it transforms the data set to a high dimensional data, to a high dimensional space, and it reduces the dimension by considering their linear combination. So the thing is, PLS is careful when it is working with labeled data because we want to make sure that we have reliable model and that the labels are already taken care of. So we have used PLS for the dimensional reduction. In this study, I started with natural language processing and I have used these three machine learning methods: support vector machine, SVM, quadratic discriminant analysis, QDA, and AdaBoost. So let's very briefly go over them, and then after applying these on my documentary matrix, I will share my results. And also for the performance evaluation, I have used ROC analysis. I will also talk about it. So the first model I have used is SVM. What is SVM? Support vector machine, or SVM, is a supervised machine learning method. So machine learning methods can be supervised and unsupervised. When we say supervised, it means that the labels of the data are already given. For example, in this study, we know that if the patient is COPD diagnosed by COPD or not. But if the labels are not given, that is called non-supervised. So support vector machine is a supervised machine learning method that can be used both on regression and also on classification. Here, it is mostly used on classification. So how it works, you have the data set and you have different categories or classes. So what it does, it creates a line or hyperlane between the separate categories in the data set. And how it does it, it maps all of the features to a high dimension and then construct a hyperplane between them. So how the hyperplane is constructed, let me explain it with this picture. So I have simple pictures to kind of show the idea. See, for example, here we have two data sets, two classes, this class and that class. And here we have a linear classifier. And what happens, you see we have the data, like this data and this data. These are called support vectors. So what it does, it looks at the margin, it creates a hyperplane in a way that this margin is maximized. So that is the way the hyperplane is created. This is called support vector machine, and just consider it in a higher dimension. The next method that I have used is quadratic discriminant analysis. So what is a discriminant analysis. It is a statistical technique used to classify the observation into non-overlapping groups. Here I have 3 groups, and you see that a linear line has been used to classify these 3 groups. So it creates a boundary between them. If the boundary has this quadratic form, it is called quadratic discriminant analysis. In the next slide, I have it in more details. So how this is done, say we have 3 classes here. So what happens, it considers every class of the sample coming from a high dimensional normal distribution. So we have 3 classes, and each of them are coming from a high dimensional normal distribution with mean mu and covariance matrix sigma. And you see that, like in this example, they have the distributions are different, but if the simplest case is when all of them have center mu, mean mu, and all of them have their covariant matrix sigma. So what happens? All of them are going to have the same distribution, right? Then the classifier is going to be a line. And instead of quadratic, it is going to be a line. That is the simple case. But in this study, we have done the quadratic discriminant analysis. And the last model, I don't want to go through the details. So what AdaBoost does, it uses weak machine learning learners, and combines them to create a stronger model. For example, this is a classifier that we have, the first classifier, which is not doing a great job. Classified, but not really well. It is a linear classifier. This is another classifier, and this is the third classifier. All of them are weak, but if you consider the weighted combination of these 3, that is the classifier that you get. You get that nonlinear classifier, and that is doing better job than these 3. So AdaBoost, basically, depending on which classifier you are using, you are just combining them and getting a nonlinear classifier. Eventually, so we talked about the models that we have used. For the model performance, I have a simple example for you. Some of you might already know this. So if I am explaining a lot, I'm sorry about that. I want to make sure that the content is, everybody can follow. So by model performance, say we have the simple population. There are different ways that you can consider the performance of your model. So look at this simple population or a sample. So what we have some positive cases, which is just 1, and 9 negative cases. So we have a classifier. Our classifier classifies it to negatives and positives. These are predicted. These are really negative, and these 7 are predicted as negative. So these are called true negative. There is no false negative, right? Because all of them are true negatives. This is supposed to be, these are supposed to be these are predicted as positive, but we see that these 2 are negative. So this is true positive, but these are false positive. So based on this count, we can do, for the model performance, we can set up these specificity, sensitivity, and accuracy. Just set up these, and these are each of these can be used for the model performance. We also use ROC curve. ROC curve is the trade-off between sensitivity and specificity. I have it in more details in the next slide. And if we consider the area under that curve, we say area under the ROC curve. So this is the ROC curve, and the area under curve is called area under curve. So we have the false positive rate here, true positive rate here, and you see that this is not a good classifier. This is a better classifier, and as it is pulled to the top left corner, it gets better and better. So 0.8, if the area under curve is 0.8, we consider that as a good model. So AUC stands for area under the RLC curve. Okay. So for the model evaluation, I have mostly considered all of this, but when it came to the results, I have considered the area under curve. So we talked about it. Let me review and see what we did. We started with natural language processing. We cleaned the data. We converted the data to the numerical values. Then we partitioned the data to training set, testing set. So the training set, we have the labels. Either they are COPD, diagnosed by COPD or not, true, false, which are 0, 1s. Then we have 3 models, which I have used. And using the test data that we have, they are unseen data. The classifier, the machine learning has never seen them, and it is not supposed to know the labels. So we used the train classifier on the test data, and we got the predictions. And these are the ground truth, the labels for the testing set. So these two are compared. And remember the performance that I talked about. I have done all of this, and I have the results for the accuracy. So here I have some numbers and details. I will go over them very briefly before sharing the result, the performance. So we started with 3,000 features, and using the PLS, dimensional reduction, I ended up with 15. 15 gave me a reasonable, good performance. And then I partitioned the data to the test and train and test. So there was a problem. I want to talk about this problem. So the data set that I had, it had 63,000 patients in it. And just 595 of them were positive COPDs. And the rest was, they were negative COPDs. And if I decided to train the model on this data, you can see that it is going to lean to predict negative because there are a lot of negatives in it. Now, this is a problem that should, if we have this case, we need to take care of that, and that is called prevalence. So to do the prevalence, what we do, we need to have a reasonable ratio of positive labels and negative labels. So the ratio I have chosen is 1 to 4. So these are just numbers. So I ended up with having, in the training, I have 1,400 something, and in the test data, which normally should be less than training data. Normally it is the case. In training set, we have more data points. In test data, we have less data points. But it was opposite here because I needed to take care of the prevalence. And these are the model performance. So the first column is the specificity. We have SVM, AdaBoost, and quadratic discriminant analysis. Then we have sensitivity, accuracy, and area under curve. So which model is doing better? First one, right? SVM. It is doing better than, and the second one is AdaBoost. And this is the area under curve I have. So this is SVM doing better than AdaBoost, and that is doing better. Oh, yes. So conclusions. We conclude that SVM did a better job compared to the other ones. In general, there are other works who have showed comparable results. But what is unique about this study is I have used text data instead of numerical data. And this methodology provides early diagnosis of COPD and exacerbation. And this we can, physicians, they can use this as an assistant tool to reduce patients' health risk. So the plan for future is I'm thinking about like using the same machine learning models on numerical data, like vital signs and respiration rate, and SpO2, which is a like a factor in the for the COPD patients, and then probably like combining this and text-based model, fusing these two to see if I can get better results. And another work that can be done, I have done some deep learning, but not very much. I was like, this can be just used on the images, because the image, like in the data set that I talked, also images are also included, if I'm not wrong. I think they are included. So using deep learning on images, I think there is another way that we can, consider. It was longer than the normal talks. I needed to do some, to review some background, make sure that.
Great.
As long as it's under like an hour.
Okay.
Yeah.
So any questions? Okay. So, yeah, you will.
For the model, do you do proper parameter tuning, or how do you decide on the parameters to use for each model?
Yeah, I did. For the feature selection, the dimensional reduction, I created a for loop because I was not sure, like the way it works, you ask the model, like what is the parameter, how many features you want to end up. For that one I created a for loop, and my intention was getting as small as possible because a lot of them were correlated. And that that for loop kind of, I was just checking to make sure that which parameter gives me. Yeah, for the dimensional reduction, which I came up with 15, I did. Mm-hmm. So Alexa was next.
Get into looking into this. So like, I guess specifically with the COPD, like is this?
Okay, so you mean like how I came up with this topic? Yeah. Okay, so when I was a graduate student, I was really interested in data science. Like my PhD was in network theory and graph, which was applied, but it was not like very applied. So I was interested in data science, and I started, watching videos, taking online courses, and there was a video by Ali. I don't remember her last name, and she gave a very interesting. Like she had a workshop, like 2-hour workshop, and that was recorded. And she talked about natural language processing, and she had some messy, like very messy data. She worked on them and like talked about the cleaning, and I really found that interesting. So that is how I started like thinking about natural language processing. And I was looking for like data set, and I had a friend, like they work in university, and I asked them like about the data, because like these data, they are so they are not available like for the public. And to get this data, I needed a recommendation from someone who works in a hospital. So like my friend introduced me to someone, they wrote a recommendation, and I got this data. And based on what Ali had there, and based on like the machine learning that I learned later, there was a course in Coursera that I took, and I kind of used some of them. And like I recently published a paper which was kind of similar, that was also natural language processing, but in that one I hadn't looked at the respiration notes. I had looked at so again, it was the same data set, which is intensive care unit. And managing intensive care units is really hard, because like they are expensive, and it puts a lot of pressure on the patients and their family, and at the same time on the hospital. So they want to empty the beds as soon as possible, but at the same time that increases the risk of readmission. So in that study, they had a column for like admission and then readmission. I looked at them, and I did not similar, but the cleaning of the natural language processing was the same. So I wanted to find what is the risk of readmission. And that was a great model, like to help them to see before discharging them, to see if it is a good idea to discharge them or not. Yeah, that is how I found out. And then in the round, because they had different categories, one of them was for respiration. So I was just curious, what is respiration? And I did some study and I decided to look at it, and it turned out well. Yeah, I am also considering like moving forward, trying other methods, and maybe kind of publishing it.
How is the model transparency? Tell how we make the decisions.
The models?
Yes. Were you able to perform any analysis that, led to
So you
having
mean-
more insight into the problem?
Using the model. So you mean like model selection, you mean, or like after selecting the
I
models?
mean, after creating the model and it being able to predict, use the data to predict an outcome, did you perform any analysis on the model itself?
No, like to
figure
choose
out
the
how
model.
to make the decision?
Yeah, the performance that I did, that kind of told me if the model is doing well or not. But there are a lot of models out there to choose. So based on if you have labeled data or not labeled data, you kind of can get a rough idea which model is going to work. So I tried a couple of them, and these three worked well. Then I looked at their performance, and I decided to move
What I
forward.
meant was, I suppose what the idea is trying to figure out the way that the model is making the decisions as like.
No, I didn't. Like, you mean like following step by step what the model is doing?
Or, to garner some sort of insight. into the
No,
problem.
I didn't do that because normally like I use Python, and in some parts I use MATLAB. So like there is a built-in model, and you,
Black box.
yeah, exactly. You put the data in it, and it gives you the result. I noticed that one of like the models are not giving me the performance that I was expecting. Like I had no insight inside the model. I knew how the model is working, but looking at the data, I talked about the prevalence. I realized that having less negative COPDs than like, I don't know how many times it was not even comparable. Like the negatives were very low. I just looked at the data and just thought about it. I didn't look inside, what is going on with the model, because there is built-in model in Python, and you just feed the argument and it does everything for you.
If you do deep learning in the future, it would be a good idea to look into ways to try to find transparency in the model.
So like I'm not sure like what exactly you mean by looking at the transparency of model. So the data set is big, and you cannot follow it step by step like what is going on. You can say that something, for example, regarding this or regarding the stop word, you keep like creating plots. I did word plot, I did histograms, and that kind of gave me an idea that okay, there are some words which are not necessary. Why I'm not adding them to my stop words? That is the way I have, moved forward to get a better and better model.
The idea of transparency. So in deep learning, like transparency is like one of the big things they're talking about now, because that's probably the largest downside of deep learning is not knowing it being a black box essentially, and having no way to figure out something new from the model.
Yeah, I see.
So you mentioned that, you had like for your whole 63,000, data points that you had, only 500 or so were positive, and you had to basically like make sure that the rate of negatives and positives was being sense. You didn't want to over
Right.
for negative or anything
Yes.
like that. What process did you go through to make sure you didn't have so many negatives? How did you pick your training data set?
So what I did, I had 579 negatives, I guess. Sure, yeah, I have them. So I have 597 positives, and the rest were negative. So what I did, I divided that by 2. So I decided to put half of them in the training data and half of them in the test data to make sure that I had enough. And then to make the ratio, I decided to go with 1 and 4. So half of that time 4 was the negative ones, and I put them in the training data set. So 1 to 4, I train my classifier based on that. And I put the rest in the testing set. I know this looks weird because normally test set is much less than training set. But I have done some, literature review, and this is how a lot of people take care of the prevalence.
Would it randomly pull? Like,
Yeah, randomly. Yeah, randomly divide them by 2, half here, half
Oh, this is all very cool.
there.
But I was really interested when you're talking about like cleaning the data or like preparing it. When like you were deciding what for the tokens, how did you like make that decision? Like, did you I don't know, like work with a physician, or is it just sort of like you look at them and you're like, this definitely has no relevance to what I'm looking for?
The tokens, you mean?
Yeah.
Okay, so I didn't do a lot of things about the tokens. I let the tokenization function, which is a built-in function in Python, to take care of that. So what I did, I have all text data for like a patient. Some of them had multiple text data. So what I did, I merged all of them and I fed them to the built-in function, and it created me the tokens. And I used the built-in stop words of the Python because there are a lot of words that, for example, some punctuations, like some of them are already defined as a stop word. So I did that, and then I had this word cloud and the frequency. I had a like lower frequency table, not table, like frequency. And based on that, I realized that there are a lot of, features which have really high frequency, but because I am not in a medical field, some of them I was not sure if they should be there or not. For example, SpO2, if I am not wrong, that is related to the oxygen saturation or something. For example, I could Google that and see that, okay, that is something that really needs to be as one of tokens. There were some that I was confident enough that can be removed. I put them in the stop word. So I created a function and I updated my stop words, and I removed them. But I might be able, if I was in a physical, in this field, I could do a better tokenization. But at the end of the day, because I have used dimensional reduction, that kind of took care of, a lot of it.
Do you want to ask a follow-up question?
Yeah, go ahead.
Okay.
I will follow up later.
So have you played around at all with like if maybe certain ones that like you weren't certain if you should make them stop words or not? Like if the results are different, if you make them stop words versus including.
Yeah, I haven't considered that, but that is something that can be looked at because still there is room to get a better performance. Machine learning field? No, I am a mathematician, so I have spent like long time to learn about mathematics, so I don't want to invest another decade of my life learning about medical. But when it comes to the research, and as long there is someone who can teach me the terminology or the issues that they are on the internet, I can do that side. But no, I am very old to consider.
The hardest part about modeling is learning the biology behind it.
Okay, don't talk to me about the chemistry. I don't like it. Biology, I can. But the thing is, for the bio, you know what my problem is? biology, I have learned everything in another language, actually, in 2 other languages. So like learning the terms, it is hard. So I need to start from scratch, learn everything. So math is easy, like no matter which language you speak, it is math. But
Language.
yeah, yeah, exactly.
When you were taking models, did you perform anything special during like crowd recognition or you just trained them normally and test them?
No, I didn't do anything special. I just like used the features and trained the classifier. Any other questions? Okay.
You know,
No problem.